chapter 4, models of the atoms. Any of this history stuff, I can't speak for what Dr. Umber is going to test you on, but I don't believe in testing students on dates and names of scientists. I think it's good to talk about them and to have heard about them, but I'm not going to ask you in what year did John Dalton propose that all matter is made up of tiny particles, because I don't think that's a detail that is critical for your success in chemistry. But I will tell you that in 1803, John Dalton proposed that all matter is made up of tiny particles. And this was somewhat revolutionary at the time. It was originally thought up of a couple of the Greeks had this idea, but they got shot down by Plato and Socrates. And so that idea just kind of simmered on the back burner for a while until John Dalton revived it. So the particles that matter is made up of are molecules or atoms. Now, we talked about molecules a little bit. Molecules can be broken down into atoms by chemical processes. And I told you, I think of atoms as being like Lego bricks. You can take a Lego structure apart, a little building or a person or a car made out of Legos. My kids are always making starships and spaceships and guns out of Legos. But you can take it apart, right? A molecule can be taken apart into the individual Lego blocks. So molecules can be taken apart into atoms. Atoms cannot be broken down by chemical or physical processes. Only are nuclear processes that we're going to ignore for this class. So Lego bricks. Can you break a Lego brick with your hands? Yeah, some of the long, skinny ones, but let's just talk about like a 2x4 regular Lego brick. Can you break it with your hands? No, you can't. So your hands, that's the physical or chemical process. Now, if you got out a saw, could you cut it in half? Yeah, you could. Is that normal playing with Legos, though? No, it shouldn't be. If it is, your kids are going to need to see a psychologist when they get a little older. Or maybe you should just start now. Get a volume discount or something. So atoms cannot be broken down. So here's a summary of Dalton's atomic theory. An element is composed of tiny, indivisible, indestructible particles called atoms. I forget where these slides are going. Okay, I can mention that later. That was his first proposal. Second one, all atoms of an element are identical and have the same properties. I will not ask you to write these 5 things out, but I want you to know them. If I ask you, well, are atoms of the same element the same or different? You should know that atoms of the same element are the same, right? That's what makes them part of that element. Atoms of an element are identical. Atoms of different elements can combine to form compounds. Compounds contain atoms in small whole number ratios. Just like when you build with Legos. You could have 1 red brick and 2 blue bricks, or you could have 1 red and 3 blue. You can't have 1 red and 2.5 blue. You can't, because you can't have half of a Lego brick. Maybe a different Lego brick that is that size, but that's a different Lego brick. And that's the way atoms are. You have whole numbers of atoms together. And those atoms can combine in more than 1 ratio to form different compounds. So you can combine carbon and hydrogen in different ratios and form a mind-boggling number of different compounds, even though the 2 elements are the same. But how you put them together makes them very different compounds. Any questions about these ideas? These are really fundamental ideas for chemistry. Well, Dalton, this is back in 1803. See, I can't remember the dates either. 1803. So we've learned a lot since then. I mean, that was before electricity, right? That was before high-powered microscopes and technology and all of that kind of good stuff. So they were really doing all of this science almost blind. They really just couldn't see what they were doing that well. It's really amazing what they could find out. So the first two parts of his theory were later proven incorrect. Let's go back to those. So this one, elements composed of tiny, indivisible, indestructible particles called atoms. What part of that do you think is maybe not quite correct? Indestructible. And to a somewhat extent, indivisible. Because now we know that you can destroy atoms. It's a nuclear reaction. You detonate a nuclear bomb, you're destroying atoms. So that can be done. Anybody have an idea about why number 2 isn't quite right?
Because there are different forms of one, like atom, like carbon has...
Yes, and those are called isotopes. And so carbon, there's carbon-12, carbon-13, and carbon-14. They're very similar, but they're not identical. And we'll learn more about those later. The remaining 3 are true, yes?
If we're destroying atoms, isn't that destroying matter?
When we destroy an atom, there's usually energy involved. And so that's why people do nuclear fission, splitting atoms, is to get energy, right? The energy that's released is equal to the mass destroyed times the speed of light squared. So the combination of matter and energy together are conserved. Good question. Okay, so I think we covered that one.